All right, so we're talking about closures. We're talking code. So let's say I have some scope here. It's got some variables in it, but it happens to be inside of this other scope. And it's got some variables in it too. This inner scope can use these variables. This outer scope can't use these variables, but the inner scope closes over the outer scope so that we can use that also. A few of you mentioned that, like, even after this outer function is complete, we still have those things. Let's take a look at what that looks like, because this is the power of closures. This is why they're awesome. All right, so if I have some function on the outside and it returns some function on the inside, but I say const A equals 1 and const B equals 2, and this returns A times B. A and B aren't in scope for that inner function. It's getting them through closure. Take a second to look at that. If I invoke that outer function, the thing that comes out of the function is also a function. I can pass that function around. I can pass it into another function. I can do all kinds of crazy shit with inner, including calling it. So when we talk about the outer scope being finished or completed or whatever, when I call outer, it executes this function, returns the inner one, and doesn't exist anymore. It's completed its thing. You invoked it. It's done. But this inner function remembers its environment. It remembers what was available to it at the time. And so then this is still going to work like that. Ask me some questions about closures.
Can you call the inner function without calling the outer function?
Not in this case, because it's being defined as part of the outer function. Since I defined it inside of there, I can't get to it without running that function.
So once you've run the outer function, then you can call the inner function as many times as you want, essentially, and it'll hang on to those const variables that you declared.
Yep, I can do that as much as I want, and it remembers them.
So what within this example, like, I guess, where does the subject of our vocabulary, where does closure actually, how do you use closure to describe this relationship again?
So let's say that instead one of these things is coming from closure and the other one is coming as an argument. So what I would say here, so now these become like something like that. We would say that this inner function gets some number as an argument, and it gets A through closure. It has closed over A. Some number is one of its parameters.
And then Kyle, is this also when, like, you could pass a second set of parentheses after outer with whatever you were trying to give to the inner function?
Mm-hmm. This is how people used to do private variables in JavaScript. So that would look something like that. If you ever see that thing before, if you ever see that thing in code, and you might, this is called an iffy, an immediately invoked function expression. They're really not common anymore. Like our need for them largely went away. But yes, like the idea there is that I can say product is that and that and shoot. In this case, it would need to also, it'd actually be like that. So I could do something like that, and now this a variable was never exposed to anything. I wouldn't worry too much about that though. It's a dead pattern in JavaScript. But yes, that's how that worked.
So does the closure have to be completed before you can call inner on its own?
Well, yeah, because this is the return value of the function, so I can't get it without invoking the function. And by invoking the function, since this is the return statement, it implies that the rest of the function's done. Now, I probably could also just like save that here, like that, and then that works the exact same way. But I think it's really helpful to think of them as boxes. This inner scope and this outer scope. Inner scope can see the outer scope can't see the inner scope. Inner scope sees the outer scope through closure.
And that only goes for if you're defining the function within the function.
Yes.
Not if you're just invoking it within the function.
Correct.
Is this
Although,
a language?
I mean, like, honestly, this is closure also. Because, so this is in the global scope. It's still an outer scope from where this is. It's anytime you do that kind of thing. You're looking to a scope outside of your own scope. That's a closure. And in that case, you don't even need like the nested function thing. That's getting a through closure also.
Is this isn't language specific, right? This is something that sort of all languages can do.
No, it is a thing that languages can do. It is a general concept, but not every language has closures.
Can you do it in Ruby?
That's a good question. I don't know. So does Ruby have closures? I think it does. Yeah, closest thing is blocks. Like PHP doesn't really have them. Like you can do very similar kinds of things, but I don't think anybody would call those closures.
Why is Ruby specifically such an exception to a lot of the rules?
Because
Object-oriented.
yeah, that's basically it. Ruby is like a real object-oriented language, and JavaScript is not. So a real object-oriented language, everything is an object. Well, that's not really the case in JavaScript. JavaScript has objects. It also has like 6 primitive types. There are no primitive types really in Ruby. JavaScript has operators like plus and divide and that kind of stuff. Ruby technically doesn't. You can write code that looks like it does, but you're still just calling methods. You're calling like number dot plus on something is like all that shorthand is. So everything is in a class and everything is an object. Even that procedural stuff we were doing with like Hashkapal and stuff, if you don't declare the class, then it's just part of a class called main. But like you can think of that as just being just off the screen. And so because of that, we don't have things like first-class functions. If you don't have a standalone function, then you can't really do a map, because a map is passing a function into something and iterating over it. So like the equivalent idea in Ruby, they hacked around their like lack of like first-class functions with blocks, because maps are the fucking shit. So that was their way to like get that into the language. But it's kind of a hack. Now, in contrast, like JavaScript is loosey-goosey about everything. You can do things that look object-oriented. You can do things that look functional, but it's honestly not much of a language for either of those things. And that's kind of its power, is that we can just mix and match and borrow from paradigms however much we want. But I would say like the question you should have asked is, why is JavaScript the exception to so many rules? Lots of languages work like Ruby. I'm not aware of anything that has as much flexibility as JavaScript does.
I guess that's why JavaScript is kind of like in between every type of programming.
Yes. It's actually got a fascinating history behind it too. The reason that it is so ubiquitous and so successful is certainly not because it was well designed. Brendan Eich made JavaScript in 10 days in 1995, and like made a lot of mistakes that he has talked ad nauseum about. But everybody doubted it, and so nobody tried to get rid of it. Like everybody, like Microsoft had a competitor to JavaScript in the mid 90s called LiveScript. Everybody was going to have their own way to do client-side scripting, and all of them were from these big heavy hitters. Everybody took them really seriously, and so they all kind of like destroyed each other. And then when the dust settled, all that was left was this little fucking stupid language for scroll effects and stuff that nobody took seriously. And it like really the big kicker was Gmail. As soon as like Gmail was like effectively the first web app, and it was using JavaScript in ways that JavaScript really wasn't intended to be used, but it showed what could be possible. And then we started adding this and this and this and this and this, and now it's a robust as hell language. But yeah, kind of curious history behind it.
That's hysterical.
Yes. Cool. Other questions about closures? All right. Let's go on to computer viruses. You guys are curious about that. So let's take another 3 minutes. What's a computer virus? Go. 15 seconds. All right, send me what you got. Great answer, Kelsey. Small pieces of software that piggybacks on real programs. They're triggered by the activation of their host. They're often attached or concealed in shared or downloaded files. It can execute malicious code and replicate to infect other files on your system. Very good. Program that replicates by modifying other computer programs and inserts its own code. Question, are they always with negative intent, or are there examples of viruses used for positive reasons? It's a great question. Malicious program that self-replicates by copying itself to another program. Purpose of creating a computer virus to gain admin control and steal user-sensitive information. Good answers. So the thing that makes a virus in particular a virus, because like, I'm going to show my age here. Not all malware is a virus. Malware is the generic term. The thing that might date me is like, when I was a boy, they called all electronic music techno. I was like, techno is a very narrow thing. Electronica is the family. So malware is the family. A virus is a particular kind. And like the big thing on viruses is the replicating part, that they spread like viruses do. So think of it this way. You have programs on your computer that can write files, right? Like even just you fire up Microsoft Word, something like that, and you hit save, and it writes a file to your computer. Well, it does that because it has the right to create files on your computer. So now let's say you didn't download Microsoft Office, you downloaded Microsoft Office. And somebody had put their own code in there so that whenever you save, it doesn't just save the your Word document, it also creates this other file on your computer. And let's say that file is a program that creates other files on your computer. And then it executes those. So they create other files on the computer, and they create other files on the computer. There's a variety of different ways that, like, or purposes. Like one thing you can do is just eat up all of someone's hard drive by making a bunch of meaningless files on their computer. If you can do it in ways that are hard to find by making them look like legitimate files, you can just like eat up all of someone's hard drive space, and you can get to the point where they don't even have enough resources left to do anything about it. Okay, that's a virus. There's a particular kind of, I guess I would classify this as it's a different kind of virus than the one I just described. Fork bomb. So these are common in, this is like the Unix virus. So forking a process says, all right, I want to keep this process running and I want to make a copy of it that I can do other things with. So that's called forking. So a fork bomb is when you do that inside of an infinite loop. And so it just forks all of your processes until you're using up all of your processing power and all of your RAM. Now you can't do anything. Now you can also have things that are like, all right, I also inserted some code in there that when you hit save on Microsoft Office, I make this copy of this file, and then when I run that file, it FTPs a copy of all the contents of that folder to my server. So when you're doing things like installing software and they're like, are you sure that you want to give administrative privileges to this? That's what they're talking about. Should this program be allowed to like read and write to your file system? Because you're inviting some risk with that. Questions about viruses?
So is the main purpose of a computer virus basically to brick your PC?
Often. It could be like extract information and stuff also. Like there's more like useful ways to different kinds of malware to do that, like Trojans and stuff. But yeah, I'd say 80% of the time a virus is just trying to hose your computer.
So is Norton just like preying on old people who don't understand the internet, or do
Correct.
individual users? Okay, so that
well, like the reality of it is like so much of these things are just built into operating systems now. And like you're even like on Windows, which is like a massive attack target. It's hard to get too much better than Windows Defender, which is free. Comes with, you have to install it separately, but it comes with the operating system. And so yes, like here's the worst part about it. Like Norton and stuff, like a lot of the things that they do to protect your computer, like are very literally making it insecure.
Yeah.
So that because they trust themselves, but like you shouldn't trust Norton as much as they're trying to get you to trust them. Or like a lot of folks will install multiple antivirus softwares, which are then competing to take over your computer. Like, yeah, there's not a whole lot of good use for antivirus software in 2020.
I hear McAfee's really good.
John McAfee's batshit crazy.
Yeah, I saw a few videos about that guy. It's pretty wild.
Yes.
It's really pretty wild. It's like
Even
living in
his
like
own
Belize
commercials about himself are amazing.
Yes.
That's what a lot of cocaine looks like.
Awesome. Other questions about computer viruses?
Could you technically like see a virus file like by LSing in your terminal? It just is made to look like something that would naturally be there.
Yeah. And like it might be, oh no, it doesn't create any of its own files. It just modifies other files. So since it inserted that code into your Microsoft Word, so whenever you save, it does this. Maybe what it does is it finds other programs on the computer, like the ls command, and adds some malicious script to the end of that. If you gave it administrative privileges to your computer, it certainly can. And so now every time you run ls, like it also makes a curl request to send like all the contents of that folder to some server somewhere.
Is there a way to save your PC if you you catch a virus at the start, or are you pretty much
It's
screwed?
different for every virus. They're way less common, and a lot of it has just been tightening up security on operating systems.
is there actual like legality that affects people who create viruses?
Oh yeah, it is like a felony to make a virus.
So I shouldn't like put a virus on the NRA website or something.
No.
Okay.
There was actually a big act. It's like the Anti-Computer Virus Act. It was called law. Computer Fraud and Abuse Act. Cool. So shit, we're at 10:54. I have a hard out at 11. I do want to talk about this MVC thing real quick. So we haven't explicitly talked that much about what this pattern is. So I'm going to give you a quick mental model that you can use. Okay, so model view controller. This is best thought of in terms of Rails. This is an old idea though. MVC predates like the web. This is a super popular architecture pattern and all kinds of different computer programs. So the idea is that as a user, so this is you, You are looking at the view of software. You are interacting with the controller of the software. The controller can do things like it can read stuff out of the model, and the controller can like bind stuff to the view. But the view doesn't interact directly with the model ever. It only interacts with it through the controller. So in Rails terms, like a view would be like the serializer or like your render method. We go real light on that around here, but think about all those actions that are in a controller. That's the thing that's actually being called when you make your HTTP request. So you interact with that, you see that, and then you interact with this model. You can write to it, you can read from it, whatever. But the view never directly interacts with that model. This is the MVC pattern. Questions about that?
What would
I
an
guess-
alternative architecture be?
There's one called model view model that's also like relatively popular. So you have a model, you have a view, and you have a view model. This is the architecture pattern that like most of the front end frameworks use. So you have a template, and you have like this binding that goes here. So anytime this changes, and this changes, they're synchronized. So anything that like is like binding, synchronized, something like that, it's probably this pattern.
I guess, would you be able to go into a little bit more detail on views, since we kind of don't really go super in depth on them? We kind of have other things that sort of, it seems like we kind of blast through them in a way, like Rails has some ways to kind of
So a
bypass
view
them.
it's a presentation of data, and is like one of many. So if the state of the application is whatever, this is in the database. This is the owner and all of their dogs. That's the state of it. I can present that as a view in all kinds of different ways. I can send it back as JSON. I can render it to an HTML file. I can do whatever. But the idea that those things are separated, that's like the key part. You're presenting existing information. You're not modifying that also. So like for anybody who's in like the DOM calculator shit yesterday, an example of violating this would be, think of the view as like the screen on the calculator. Every time you read something off of the screen and then do a calculation with it, you're violating this, because you're not supposed to read data out of the view. The view is supposed to represent some kind of internal state in the calculator. You can think of the buttons as the controller for it. Those are like changing these things in the state. But if we were following MVC with the DOM calculator, we would have some canonical state of the calculator. That's the model. The controller is updating that. You could also, I've also seen people rewrite this kind of like this, where the view is just reflecting whatever happens to be in state. And if that needs to be changed, we go through the controller to do it. And then the view is just reflecting the change in the state. But you wouldn't read off of the view to be any kind of authoritative state.
Is that because you could render stuff that's not necessarily been sent to the database?
Exactly. Or something that's calculated. where like it's not state itself, but it's derived from other things that are state. We want all of that to live in one place. Otherwise, if anything is allowed to modify anything, it gets very difficult to figure out what did modify something. So we present a bunch of stuff. That's what we see. And like see, like it doesn't need to literally be seeing. This could be played an audio file or something like that. That counts as a view in this kind of thing. But it's presenting data. We interact with a controller. The controller can modify state. Then like, you could either say like the controller renders the view, or you could say like the view represents what's in the model. Cool. I got to bounce. Let's keep doing this. This is fun. Great work, everybody. See you soon.